Let's talk about how you execute the iterations in a program increment. First, teams plan and commit to an iteration. The iteration is the basic construct. It is the fastest PCDA cycle inside SAFe. The purpose of planning is to define and commit to what will be built in the course of that single iteration. One team, one iteration, one plan. The process is the product owner defines the what. They're the keeper of the backlog. They describe what we'd like to accomplish in the time frame. But only the team who does the work defines how and how much. 4 hours maximum can even be a lot less. The result is a set of iteration goals and a backlog of the team's commitment for the upcoming sprint. In addition, in accordance with that commitment, we look at that as a reciprocal commitment. In other words, the team commits to delivering a specific value. They did the planning, they have the resources, they can define, build, and test the thing of interest. The business has to commit then to leaving those priorities unchanged during the course of the iteration. If that's not the case, then the team's commitment obviously can't be any good because they didn't commit to doing anything that can be done in a 2-week time frame. They committed to a specific course of action. And if management intervenes with that in the course of a short 2-week sprint, then all bets are off. Doesn't mean you can't do it. It just means that it destroys some of the basic cadence and deliverables of the iteration. Let's talk a little bit about executing that iteration. Let's talk specifically about some of the patterns and anti-patterns that we see in that process. This first pattern is in what we call an inter-iteration waterfall, and it's not a good pattern. And the reason is the teams are using the time boxes simply to do what they've always done, which is to waterfall the work in terms of definition, building, test, validation, acceptance, etc. The fact that they have a PI time box can even lull them into a false sense of security that says we have 10 weeks to get all this work done. In iteration 1, we'll define the work, we'll get started a little later on, we'll start doing some testing, we'll do build and test. In iteration 5, which is our innovation and planning iteration, we conclude testing. Well, obviously all you've done is take one big waterfall and convert it to a smaller one. That by itself isn't bad, but it's not agile. It's not the way we would really want to approach the problem. Now, this looks better, and some would say, that's not so bad. We get done with all of our work during the course of an iteration, so maybe this is wrong. Maybe it really should be okay, right? Maybe that's a check. Well, it isn't a check, and the reason it isn't a check is that, yes, it's true that the work is being done during the course of the single iteration, but all the testing is stacked up to the end. So consequently, you have, again, delayed risk and delayed discovery of the assumptions that have proven to be invalid during the course of that iteration. So even though it's a big improvement over this one, I mean, at least we have the option to have real value at the end of the iteration. And notice up here you don't, right? These aren't real iterations. There's no deliverable value here. There's no deliverable value here because nothing's tested or accepted. So what's far preferable is the notion that we take that little slice that I described earlier in the course, this define, build, test slice, and we do that, and we deliver a story. So if there's 5 or 10 stories in the course of a single sprint, well, why would we wait until the end of that first iteration to deliver the first story, much less to iteration 3? We want to do that right away. And this is linear flow. When we talk about flow, that's what we're talking about. Second day of iteration 1 in the PI, there's some new stories that are available. And they're available for not just this team, but the other teams that use them, because other people want to take advantage of those stories. And indeed, I may have a team that's fully dependent on that particular story. So if it doesn't happen till here, and it could have happened earlier, then they're delayed. So there's a cost of delay that adds up in that process. I wouldn't call it ideal. I would call this as just the right way to build the iterations, a fully cross-functional. Deliver stories iteratively and incrementally through the course of an iteration. No deferred risk discovery. Right here, we discovered that this story did or didn't solve its problem, and if somebody else is using it, we'll have that feedback right away. We don't have to wait for the system demo to understand that. Built-in quality. I mentioned earlier the value of quality and the fact that it's a core value in SAFe, and the reason is very simple. People use SAFe and the lean agile methods and principles that underlie it to build really big systems. But I was on stage one time and I had this slightly inappropriate comment that people tweeted immediately. I said, you can't scale crappy code, and everybody laughed because it's true. How do you build a big, high-quality system out of small, low-quality components? The reality is you can't, just the opposite. Whatever defects you have associated with the subsystems, the components, or the features, they're going to aggregate and they're going to exponentially increase. You're going to have new types of defects that are simply the accumulation of multiple small misassumptions and stack overruns and memory leaks and other things that happen during the course of developing the actual feature. So you can't scale crappy stuff. We need to build stuff right in. And as I mentioned, that's a key principle of lean. That's building quality in is simply what we do, because that way you don't have to revisit things. That way you don't have to drop your synchronization and jump back 2, 4, 6 weeks back into a piece of code that should have been validated at that time. So the result of this process is really all good. Every increment of the solution reflects quality standards. So we don't add quality later. We know how difficult that can be, virtually impossible in some cases. You don't really have a choice, because if you want high sustainable velocity and not false velocity, yeah, we delivered 30 points in each of the last 4 sprints, but now here we are at PI time, we're in the innovation, and it turns out the last demo didn't go very well. So these next few weeks, we're going to spend all of our time, fixing the stuff that we should have fixed earlier. Now, the very notion of a story really helps, because each story delivers value, and those stories aggregate into features. So instead of thinking about, line 13 in the requirement specification, did we do it or did we test it? We think about specific actionable user stories that each would deliver value. And the combination of the user stories that are implemented in the course of an iteration creates the value for that particular system increment. Now, we're not going to talk much about these, but we're going to briefly introduce a few key practices. With respect to software, they're primarily inspired by extreme programming. Maybe there's not so much bloom on the rose around XP right now. Maybe pair programming was a bridge too far. Maybe those authors moved on to other things. But I, for one, have a tremendous respect for the work that was done prior to the time that I entered the Agile arena. And I was introduced to Agile not through Scrum, the most common model, but by XP. So principles and practices like continuous integration, test first, or TDD in the context, test-driven development in the context of a more basic XP paradigm. Refactoring, why do we refactor work? Because if we're going really fast, even if it's quality, it may not meet the actual user needs. So we may have a good method and it may work great for the method that we implemented, but we may discover, because we didn't have a long-term view of the system, that we need to make some changes. That's okay. Pair work, collective ownership, and more. We'll talk about a few of these further in this module. Hardware quality is essential as well. There's a different set of practices, including exploratory early iterations, frequent system-level integration, design verification in flight, model-based systems engineering, and set-based design. We won't go into those in any depth, but each of those is a fairly simple click on the framework, and you can find more about those at your leisure. Now let's talk about something that tends to bedevil people when they think about solution development via Agile methods, and this is the notion of emergent design, right? The best requirements and designs emerge from self-organizing teams. We believe that, and that's part of the Agile Manifesto. We have a slightly broader view. Every team deserves to see the bigger picture. Every team is empowered to design their part, and there in that intersection is where we start to think about how emergent design and intentionality work together. Well, what is emergent design? Well, for us, our view of that is teams grow the system design as necessary for each user story that comes along. They have some notion about the upcoming future, but they're not overly concerned about the third or the fifth or the eighth sprint down the road. As new user stories come upon them, they'll refactor the design and modify the design as necessary to accomplish the new functionality. That avoids the big upfront design paradigm that we're so familiar with. It's not only is it part of waterfall, it kind of is waterfall. Intentional architecture is something different, however. This fosters team alignment and helps define the architectural runway, which is an important construct in SAFe that I'll talk about in just a second. The balance is interesting, right? A balance between emergent design and intentional architecture is required. And the reason is we need to go fast. We need the teams to be able to quickly respond to new user stories that come in to their view and need architecture and design work. They need to be able to make the changes to support the system to do that. At the same time, we want to be confident about some things that we know. We want to implement this design in a way that's consistent with a slightly longer term view. So this means that we have to have a balance between emergent design and intentional architecture. And that's how we can go fast and build robust systems. The two work together. Let's talk a little bit about intentional architecture and this notion of architectural runway. Well, what is it? It's not a model, and it's not a picture of where you're headed. It's existing stuff. It's existing code, hardware components that technically enable near-term business features. What do we mean? It means that if I have a new feature, I want to be able to do it in a short time box. Let's just bracket this inside a PI. Well, if I don't have the capabilities, the technical capabilities, using the term generically, to support that feature, I'm going to have a hard time doing that, because I'm going to have to rototill the architecture a little bit, add the feature in, validate the feature, and get feedback all in a very short period. And if you're building a big system, 8 or 10 weeks is really short. We need more than that. We need some capabilities already in the system. Here's an example. I might want to do a variety of things around a search engine. I might want to be able to do autocorrective spellings. I might want to be able to do a table lookup of like places, even if somebody didn't get the location right. Well, how can I do all of those things? Well, I'm going to need a fuzzy search algorithm. I need to have the ability to have parameter-based searches so that when the search goes in, I can walk it through a range of options. Well, once I do that, I can handle a lot of problems. I can handle simple spelling corrections. I can handle the ability to understand the user's intent, even though they typed in the wrong city. There's another city that has a similar name, and the city pops up. So enablers, this little red box on the left over here that we haven't yet discussed, we'll discuss it very briefly, build up the runway. This is work we knew. So this is an example. We'll build this in. Product manager may or may not say, I need a fuzzy search algorithm. That's not language they would use. They might say, we need the ability to correct spelling errors when somebody types in a name on a search engine. And also, we need the ability to understand the user's intent if they make a logic error in their query. Well, this is our answer for that. We're going to build that capability, and then we can support a variety of these features down that path. We'll use enablers to do that, as we'll see in a second. Features consume it. Well, what do we mean by that? Well, we use that architectural runway, and that feature used some of it up. So it's great. Now, consequently, I've pretty much taken advantage of all that infrastructure, and I've gone as far as I can with the existing fuzzy search algorithm. So at some point, we're going to need to build it up further. And if we maintain it continuously, then we have a process that basically says, our velocity can be very fast, and the reason it can be very fast and stay fast is that we're constantly investing in the architectural runway for the system. And we must continually maintain the architectural runway to assure that we have a steady long-term velocity. We can go fast only when we're constantly investing in and applying the architectural runway to the new feature work. How do we get that runway? Well, if you look at the program backlog article on SAFe, you'll discover this notion of capacity allocation, which is a fundamental lean construct. Lean is not particularly extreme in any case. One thing that is extremely explicit in lean is that your capacity, 100% of your capacity is your capacity, and there isn't 110%. So if we're going to do both this work and this work, we may want to use a capacity allocation, typically looked at as some form of pie chart that says for this upcoming PI, we'll have this percentage of our work devoting to enablers. All the rest is going to be devoted to features. So capacity allocation is a way to think about that. And that's how we can make sure that enablers are built into the process. And they must be visible as well. So let's talk a little bit about this new word, enablers. Well, what are they? They're technical initiatives, right? They're not necessarily user-facing. Rarely are they. If I'm going to update to 64-bit back office servers, that's a pretty big job, and it's pretty meaningful to the business. So it has business value, but does my user care? I don't think they care. They exist at all levels of SAFe. So when you look at the picture, you're going to see enablers at each level. You're going to see them at the portfolio level. You're going to see them at the value stream level, the program level, and the team level. Do you need them at every level? Well, probably you do. And if you don't apply them, sometimes it's assumed that I'll just go in and refactor a piece of code. But we use this word to describe various levels of effort associated with that. An enabler story might be a simple thing to refactor an algorithm to run a little faster. An enabler feature might be, for example, the one I just showed you, an enabler capability, enabler epics on up through the stack. However, they usually fall into one of three categories, and when you see on the big picture, you see exactly that. You see enablers are used for exploration. Maybe there's a spike that I need to do some research. Maybe I need to establish some requirements and validate those with the customer. Maybe I want to work on an API and test the API without any code behind it. Maybe I want to work in a different programming language and do, just do a mock-up or a prototype. Lots of different things I might want to do along here to explore how I'm going to build my future system. Architecture enablers, well, that's the example I just showed you to build that fuzzy search algorithm. And an infrastructure enabler, what if we need to update the lab, or we need to build a new staging environment? Here's production, here's the development environment, and we're going, they're not alike. So I want to build a staging environment that essentially emulates production, and I want to deploy to staging. Well, I have to build that environment, and that's going to take time and effort. Nobody's going to build it for me. My team or my program is going to be responsible for that. So that's an example of an infrastructure enabler. This is an important category of work. Why does it have to be visible? One is the work won't get done because nobody's focused on it, or two, it will get done, but the teams won't get credit for it, or it will appear as delays in the value stream because we really didn't anticipate that work. I'm going to take all that back and just basically say, and enablers need to be visible, because if they aren't visible, the work simply isn't going to happen. Let's talk about system integration and continuous system integration. We certainly understand, especially on our software assets, that teams can and should continuously integrate their assets. And we talked about the system team earlier, and sometimes the system team plays a significant role in that, but it's not the system team's job to build the system, right? The system team's job is to be able to validate the system and help the teams increase their capability to enhance the technical capabilities they have to build a system. So we want the teams to integrate every vertical slice of a user story, and XP teaches us that. It says, well, we don't want to just even check out the entire user story, because that might take 3 to 5 days. What if I did this piece and check that in? Then guess what? That team is now using that, whereas otherwise they were going to be waiting for that. So rather than waiting until a complete story is done, this verticalization, this is kind of the micro incrementalism that XP teaches us, and that's a very effective way to make sure that everybody is working with the latest stuff and that stuff doesn't stay checked out too long, because when it stays checked out too long, what happens? We check it back in. This team was working on that assumption. Now we've broken their code, so we're already back in a rework cycle, even in a very fast development environment. We want to avoid physical branching. Why? Because every physical branch becomes a set of assumptions that needs to be merged again. And we have seen some very large programs, very large solutions, if you will. One that had, I think, 800 or 900 different people working on it, and they only had 3 branches. They had the main branch, which was a production branch, so in a way that's not a branch. Well, it is a branch, but of course, it's the one that we produce from. They had the development branch, and they had literally, hundreds and hundreds of people contributing directly to the development branch, and they had a research branch. So if you wanted to go in and break the build for a while and mess around with a brand new algorithm that's not ready for prime time, you would work there. So that's 3 branches, but 1,000 people with only 3 branches, that sure beats each team doing a branch for every single feature. Hardware needs to be integrated as well. Obviously, there are physical constraints involved. I can't just take 2 different circuit boards where I'm prototyping different aspects of a microprocessor-based power supply and just, shove them together. There are physical constraints to integration there, but we want to integrate absolutely as frequently as we can. And in case of inter-team dependencies, we want to define the interfaces and integrate first. And by the way, that's one of the key techniques for working with teams and programs that are working with waterfall development, which is, they don't live in a little box called I can only code right now. Those are smart people too. They just happen to be using a different process model. So when we define the interfaces and integrate first, then we know that it's no longer assumption-driven development, right? We've established an agreement to what those 2 different pieces of code are supposed to do. Let's talk about what we describe as test first. And you notice the bullet up here, automate now. Why? The reason is that if I don't automate this test, let's just say I run a manual test here. Well, that's not so bad, is it? Except it costs money. And I'm going to run that same test again, and it costs money. And not only that, the time it takes is going to start to increase. Pretty soon I have a gigantic slew of tests to run, and that's going to introduce delays into the system. So we don't want to do that. Instead, we want to automate the test in the same iteration as the functionality is developed. And that means that the team builds the functionality, builds the test at the same time. So there's no, hey, I have some functionality, but I didn't build the test. The test is part of it. In some cases, the test is written first. That's test-driven development. Build the test, build it into the system, execute the system, and watch the test fail. That tells you that it fails for a good reason because the code isn't there yet. But when you write the code to pass the test, then you know you have 2 things. You know you have the code, and you know you have the test. Typically, we need a separate environment for that. We need a place to locate those tests so that teams know which environments they can access to run them. The test data needs to be under version control too, because the tests are just as important as the code. We can't ship the code without having the test passed. So if we allow the test to deprecate over time, and they get worse and worse and they're not automated, we're eventually going to end up with a failing test. So we want to make sure that we have those under version control, just like the code that we're testing. And of course, passing versus not passing tests and the number of tests that are currently broken are the real iteration progress indicators, because then we know not that simply the code works, but all of our tests are passing or they're not, and now our velocity is real. So whatever velocity we thought we had, 35 points or whatever, that's a real velocity now, because we're achieving that essentially each and every iteration and each and every day. Scrum defines a few critical ceremonies, and one of those is the team demo. And we're big fans of the team demo because this is where you know you've accomplished what you thought you were going to accomplish. So this is the true measure of progress. This is where you see working software, working hardware, all the elements of the system. The demo preparation, you have to prepare for the demo at the start of planning. Teams demonstrate what? Well, they demonstrate every story and spike and refactor and non-functional requirements that they've achieved during the course of that iteration. Attendees are the team and whatever stakeholders want to participate in that. Let's talk about the retrospective. The retro is integral. We see here right at the manifesto level. At regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. You can run a retro a variety of different ways. We provide a sample agenda in SAFe and some guidelines for that, but there's a lot of ways to run retros. We're not particularly concerned about what your retro style is, and indeed, changing the retro style over time helps bring the attention to the retro. But it's not optional. It's something that happens every iteration. And now, as we move forward in time and we start to, put the method wars behind us, the Scrum, v Kanban, v XP, and we recognize that all these methods are optimized for different things, and Kanban is optimized for visualizing flow and managing work in process. So here's an example of a team's Kanban board. This is our backlog of upcoming stuff. They analyze work. Oh, this is interesting. Gosh, should there be a subject matter review? Well, maybe they have to have a security architect sign off, or maybe there's a verification and validation step that's necessary before it goes into the build. Maybe not. Certainly that team has an interesting challenge associated with that. But if that's their case, let's see how it works. And then maybe in progress and ready, whatever. It doesn't matter so much. You can, with the Kanban board, you start with what you're doing now and you start looking for bottlenecks. I briefly mentioned the cumulative flow diagram, which basically shows you the amount of work in process in the system at any point in time, as well as the lead time, the current lead time associated at that point. Our lead time was that many days. The Kanban systems allow us to visualize the work, establish the work in process limits. These are the work in process limits. Notice that this is higher than this one. Why? Because this is a buffer state. It says, it's ready, but it hasn't yet passed whatever definition of done we have in order to make it ready for subject matter review. So we have a low limit here because we don't want to do a lot of analysis work, but we can stack up a few here. The same here. Lots of things can be ready. Now, these are arbitrary. These are what your team decides based upon the flow through the system, and you tune and adjust these. These are not safe numbers, it's just an example. And I just illustrated an example of a ready buffer up there. If you look into the Kanban world, you also discover that there's classes of service that help you manage the flow of work. And by the way, ITIL and many systems that manage work have similar types of constructs. Standard class of service means, the cost of delay is linear. Fixed date means it's nonlinear. Expedite means you better get this thing out right away, or whatever other classes of service you want to provide. And as I mentioned, the CFD is a common tool for Kanban teams to measure their throughput. And then based upon that model, you'll discover some things. You might discover that we're really backed up in the subject matter review, and we'd really like to not have that. We'd like to have that subject matter expert part of our team. You could potentially eliminate that entire state. Or if we discover that, we can handle another story in process, that's okay too. It's up to the team to describe those limits and to modify those limits to manage their flow.